All right, so all I have at the top here is literally just, it says, sometimes it might not be really easy on a graph to identify the point. Maybe one of the x-coordinate or y-coordinate might have a decimal, so it wouldn't be easy to see on a graph. So in that situation, we're going to want to make sure we use algebra to solve instead. Now, most of these questions that we're going to do together today have nice answers for x and y, just some examples. There's a couple on the homework that might have a decimal or fraction. I'll try and remind you of that as we get closer to it. But you might want a calculator today if I didn't already say that. So we're going to work on the substitution method today. So no graphing involved. Does anybody remember? And if you want to look down, like these are systems that are on the page here that are kind of set up to solve by using substitution. Does anybody remember kind of like what's the process that you use if you want to solve a system with substitution? Like what do you end up doing as you solve the problem? Does anybody remember? Or maybe what I'm looking for if I want to use substitution? You guys remember this at all? If not, it's okay, I can write down. Anything you're looking, like if you looked at either one of these questions and I said, let's solve by substitution, like what would you end up doing? Do you remember? Yeah. Yeah, you plug one equation into the other. Okay, what you're looking for here, well really, when we plug something in, what you're looking for is you're looking for one of the equations that has a variable alone on one side. So if you look down to my example number 1 there, you got like a y by itself on one side, or you got an x by itself on one side, or you're looking for an equation where it would be easy to get a variable by itself on one side. And then what you do is you plug in what your variable is equal to. And then, sorry, this is long, I should have worded this better, into the other equation in your system. So you're looking for one of the equations to have a variable all by itself, and then you're going to take whatever that variable is equal to and substitute it in place of that variable in the other equation that you have in your system. And that is probably a really long-winded way of saying what we're going to do in this first example, which is not going to be as confusing as what I just wrote, I think. Okay, so if you're going to use substitution, this actually would be a decent one for graphing too. Both of these are in slope-intercept form, but I don't have a graph on the paper. So let me use substitution here. And it doesn't matter which one. You're just looking for a variable by itself. In this particular example, both of those equations are set equal to y. So just grab one of them. You're just going to take what y equals and substitute it in place of y in the other equation. So I'm taking, and the way I set that up just now, I'm taking the first equation, I'm just going to take what y equals and place it in for y in the second equation. So instead of writing y, just write what y is equal to. So you got 2x minus 3, and then keep that equal to 5x plus 6. We're taking two equations with two variables there, and by substituting, what I'm creating is one equation with one variable, so then we can solve for that. Okay, anybody want to walk me through kind of how they would solve that equation real quick for x? Just raise your hand and tell me. How would you solve that? There's different ways to do it. Yeah. Okay. All right, so I got negative 3 equals 3x plus 6. Then what do you want to do? Subtract 6, okay. And then I got, let's see, negative 3 minus 6. We're getting more negatives, so it'd be negative 9 equals 3x. And then what do I do? Divide by 3. So what's my x going to be? Negative 3. Okay. Am I done? Okay, this is tricky. So raise your hand and tell me, like, what else do I need to do to get my answer? Solve for y. Okay, so ultimately you're trying to figure out, if we were to graph these, where do these intersect in the coordinate plane? So if you got one variable, you have half your answer. So I need the other variable, which is y. So if I know x is negative 3, does anybody remember how I might go about figuring out y? Yes, does it matter which equation I use? No, okay. So either one of these equations is completely up to you. You're just going to substitute this, either the first one or the second one, either one for
x, and then you'll find y. I'm just going to go ahead and use the first one. So the first one says y equals 2x, but now I know that x is negative 3. So I just substitute this in place of the x. It's 2x minus 3. And of course, you guys can grab a calculator if you want to, or you can do this by hand. Let's see, 2 times negative 3 would be negative 6, and then I would subtract 3 from that. So the y coordinate of the point where these guys are going to intersect is going to be negative 9. Now, as long as you have both the x and y coordinate, that's good for me. Like if you were doing this on a test or a quiz, I would totally take credit as long as I can see what both variables are. Technically, the answer to the question is a point. So if you want to write it as a coordinate in the coordinate plane, you would just write the x coordinate first and the y coordinate second. And so the I'm not on the screen, forgive me, the intersection there would be the point negative 3, negative 9 if we had those guys on the graph. Anybody having a question? Okay, now the one next to this just looks totally different, but it's also kind of set up to be a situation where substitution might be a quick way to solve the system. So I've got just the first equation. I've got negative 6 equals 3x minus 6y. And then my other equation, I have x equals 4 plus 5y. If you were going to try and solve that using substitution, can anybody just raise your hand? Like, how would you go about, or what would you substitute if you were going to try and solve that second system? Perfect. So this one, I got x by itself. You just take what x equals, and you're going to sub that into the other equation. Now this one's going to look a little different as we do the algebra, but it's the same concept. So I'm taking what that variable x is equal to. So instead of 3x, just everywhere you see an x, you're going to write that entire expression. So it's going to be 4 plus 5y. If you got a couple terms like I do there, what I would tell you to do, just put that in parentheses, and then don't forget the rest of the equation. So the rest of the equation, it was 3x minus 6y. So this is 3x, basically what I've just written with the substitution, and then minus 6y. Okay. Who can help me simplify that so we can solve for y? Like, what would you do next if you were trying to solve that equation? Yep. Yep. You're close. I just got to do the 3 times the 5y, so let me just write that real quick. So that would be 15y. That'll drop the parentheses, and then we can combine it. I think you were doing 5 and 6 multiplied together. We don't want to multiply, we're going to end up just multiplying the 3 by the 5y. Once you're there, then you can combine your like terms. So I've got 12 here, 15y minus 6y, they both have a y. So you're just going to do 15 minus 6. Oh, yep, and then I'm going to have 9 y's there. Okay, now from that point, I would just do 2 steps. I'm just going to move the 12. So the 12 is positive, so to cancel it out and get it away from the 9y, I got to subtract it. So 12 minus 12, 0, that goes away. On this side, you got negative 6 minus 12, so I'm getting more negatives. So this is going to be negative 18. And then I had the 9y, and then all you got to do, just divide by 9 real quick. So y is going to be negative 2. Now, this is really similar to the last question. I basically only have half of my answer because I only have one of the coordinates of the point where these 2 lines are going to intersect. Now, the last one, you can, and this is true for this one too, you can plug back in the variable you get to either equation, but sometimes one might be a little easier than the other. If you were trying to find x, like I know y is going to be negative 2, is one of those equations, like is the first one or the second one maybe a little easier to use just to save you some time? Like which equation would you plug in the negative 2 for that might make it easier? The top one? Or the bottom one? If I'm trying to find x. They'll both give you the same answer, honestly. I was just going to tell you, the variable I want that I don't know right now is x. This one might just be a tiny bit faster to save you some time because it's already solved for x. You can plug it into either equation, honestly. It doesn't make a difference, but in that particular problem, I might recommend plugging that into the second equation So that way I'm just going to have to do a little simplifying. I won't really have to solve anything because I'm just going to end up doing 4 plus 5 times negative 2. So this is going to end up being 4 minus 10. So their x is going to be negative 6. You should get the same thing for x if you plug it into the first equation, but occasionally when you do these substitution problems, there might be one equation that's a little bit easier than the other. Okay. Is anybody having a question so far? Okay. So both of those had answers. Sorry, I should write this real quick. If you want to write this as a point, this would intersect at the point negative 6, negative 2. We were on the graph. Now, these other two at the bottom, my example 2, it says special cases. So if you guys remember from yesterday, we had like infinite solutions as one of our options for a system, and we also had parallel lines, which would be no solution. So I just want to show you what those look like algebraically, so that's what we're going to run into here. So for substitution, I'm looking for a variable alone on one side. So in this first equation, right, I've got y equals negative 3x minus 8. So I would just sub that in for y in that second equation in that system. And when I do that, it's just a plain y by itself. So I can really just copy that expression. There's nothing to distribute or anything like that. It's literally just plus y. So y is negative 3x minus 8. And then that whole equation on the second line is equal to 10. Okay, here's the deal. The 3x minus 3x cancel each other out. So those are just gone. They're on the same side of the equation. If your variables all cancel out, it's going to be a special case. So on the last two problems we had x and y, they were still involved. If your variables cancel out like they did here, you're just going to end up with two numbers. So you got to ask yourself a question. Is negative 8 equal to 10? Like true or false? False, right? Okay, I know it's late in the day. All right, this is not true, right? This is false. Negative 8 is not equal to 10. So if it's not true, and my variables canceled out, okay, what do you think that means in terms of the system? Like, how would I answer how many solutions it has or what the solution would be if it's not true? No solution. That's, okay, not true is going to mean no solution. Now, this is what I'm looking for your answer, right? In reality, what that means, if you have two lines, that means that these two would be parallel lines there if we were to put them on a graph. So if you get your variables cancel out, it's not true, that means it's going to be two parallel lines. If your variables don't cancel out, then you'll have an answer, but if they do, you're going to have one of these special cases. Okay, now here's the other one. This is what it'll look like. Again, it's really set up for substitution because I have a variable by itself. I have x by itself in that first equation. You're just going to take that whole expression and put it in place of x everywhere you see an x in the second equation. Now, that has a 4 in front of it. So if you all have what I have here, I have an expression for x. Just make sure when you put the 4, just put little parentheses around it because we're going to have to do a distributive property here. So I'm going to place the 5y plus 3, that whole thing what x is equal to, and then I'm just copying down the rest of the equation. I'm going from two equations with two variables, x and y. I'm taking this down then to one equation with one variable. That allows us to solve for it. Okay, just a little distributive property here, right? Just 4 times both pieces in that first set of parentheses. So you're going to get 20y plus 12 minus 20y equals 12. And very similar to the last problem, I got a positive 20y, negative 20y on the same side, and they cancel each other out, so they're gone. Now, on this question, I end up with my variables canceled out, and I have 12 equals 12. So is that true? Yeah, 12 is equal to 12, right? Okay, if this is true, no variables, so I don't have a specific answer. I just have a true statement here. What do you think that means in terms of your answer? Infinite solutions. Now, I know it doesn't look like it in the system, how it's set up. It's not like really obvious, but those two equations in that situation, that just means they must be the same line. They're just written in different formats in that system, so it's not really obvious, but those two equations would be exactly the same line if you were to put them on the graph. Okay, does anybody have any question? We're just gonna do a couple situations on the back. This is gonna be substitution, but we're gonna set up the equations from a little bit of a word problem here. Okay, now, here's my first one. The hardest part here is not solving, it's setting it up, right, from the equations, or from the information in the problem. So this says, we have a company and they're gonna spend 12 grand for equipment to make footballs, and each football costs $3 for them to actually make it, all right? So they're spending $12,000 to get whatever equipment they need to produce these, and then each football costs them, with materials, labor, whatever it is, it costs them $3 to make it. Okay, now it says the company sells the football for $9. So that's what, like if you went to the store and bought this, it would be $9. Now it says set up and solve a system of equations to determine how many footballs the company has to sell to break even. Does anybody that, like, in business, what does it mean to break even? Do you guys know what that means? If I'm a company and I'm selling a product, what does break even mean? Exactly. So you make back all the money that you spent. Okay, so here's what you're going to do. You're going to make one, these are both going to be a cost. So this is, one equation is going to be the cost to the company, and the other equation is going to be the cost to the customer. And the break-even point is going to be when these two are equal to each other, when the cost to the company and the cost to the customer is the same. Okay, so what in that problem is a cost to the company? Like if I set up an equation to represent the cost to the company, what would you pick out of that little couple of sentences there that would be the cost to the company? What would you write down? What do you think? Mm-hmm. Perfect. Okay, so they're going to do $12,000 just for the equipment, right? That's the cost to the company. And then it also costs them $3 for every football that they make. Okay, so just so we all have the same thing, I'm going to let X be representing how many footballs they're going to make and sell. Okay, so you can use a different letter if you want to. So it costs them $12,000 just flat rate for the equipment, plus $3 for every football. How much does it cost the customer to buy a football? And then they don't have any costs to them. They're not making anything, so it's just whatever they charge for it, so it's $9. So what you're going to do, we're just going to set, these are both the costs. The cost of the company, cost of the customer is the same. You're just going to set these two guys equal to each other. So $12,000 plus 3x, that's your company cost. $9 per football, that's your customer cost. So if I just subtract 3x here real quick, I'm going to get 12,000 is 6x. So basically what's going on here, the company makes the $6 profit on every football they sell. You're trying to figure out how many they have to sell to pay off that $12,000 in equipment. After this number, each one would just be a profit. So I'm just going to divide by 6 real quick, and that's just going to give you 2,000. So they just have to sell 2,000 footballs, and then they have broken even. Now, a lot of times when you guys do the word problems, they're not like the ones that we did on the front. You don't have to find the other variable here. It doesn't ask you what the cost is. It just says how many footballs. That's what the 2,000 is. So we don't have to plug anything back in or figure anything else out. If you wanted to, though, you could plug that back into either equation. The cost would be there the same to the customer and to the company. Okay. Now, this one's a little bit weird. And I'm going to grab my calculator for this one real quick because I'm going to multiply by something. But it says you have a part-time job delivering packages, and your employer pays you a flat rate. They just pay you $9.50 per hour. You discover a competitor pays employees $2 per hour, which obviously is way less, but they pay them $3 for every delivery. And it says how many deliveries would the competitor's employee have to make in 4 hours to earn the same pay as you earn in a 4-hour shift? Okay, so in a 4-hour shift, right, if you're just paid $9.50 an hour, I'm just going to take 4 times $9.50, and that would be what you would make. So this would be $38. So if you work a 4-hour shift, it doesn't matter how many deliveries you make, you get paid $38. Okay, now the competitor pays $2 an hour, so they're also going to have the same shift. So 4 hours at $2 an hour, plus they make $3 for every delivery. So you can use whatever variable you want. I'm just going to use the letter D for delivery. And I'm going to simplify this just a tiny bit. So 4 times 2 would give me 8 plus $3 for every delivery. So in a 4-hour shift, you would make $38. In a 4-hour shift, the person at the competitor's company would make $8 plus $3 for every delivery. So we want to see how many deliveries we would have to make it maybe better to work for the other person. All right, so I'm going to put 38 equal to the 8 plus $3 a delivery. And this will be a nice number. So this is going to be 33 times the number of deliveries, divide by 3 there. So this means if you made 10 deliveries, they would be the same amount. So if you were delivering more than 10 items, it would be better for you to work for the competitor. If you were delivering less than 10 items, it would be better for you to just stay at the job you were at. Does anybody have a question? Okay, I have one more, and this one can be tricky. Okay, so jar contains, I feel like there's always coin problems like this on like SAT, ACT, all this stuff, so I try and do these in class to help you guys with that. Only nickels and dimes in a jar. It's totally normal to have a jar on your counter that only has nickels and dimes. I know. But anyway, it says there's 3 times as many dimes as nickels in the jar. The amount of money in the jar is $4.90. We want to figure out how many of each coin. Okay, so I'm just going to jot down something just really quickly to ask you. And I know you know this, but I want to make sure we write it correctly. So if I let N be nickels and D be dimes, how much is a nickel worth? 5 cents. How do you write 5 cents like as a decimal? 0.05. I cannot tell you how many people will accidentally just write 0.5, and that would really be 50 cents. So just be real careful with that. Now, for your dimes, right, dimes are 10 cents. Just as a little aside to think about that. Okay, you're going to have 2 equations here. I'm going to deal with the first one with just the amount of money. Okay, so the amount of money in the jar is $4.90. The other one is really tricky, so I want to talk to you about it for a second. Okay, so every nickel is 5 cents. So I'm going to do 0.05 times my number of nickels. And every dime is 10 cents. So I'm going to do 0.10 times my number of dimes. You really don't need the 0 that I wrote there. I just wrote it so you can see that that's 10 cents a little more easily. And then I'm going to set that to the total money amount in the jar. Okay, now the other one I think is very tricky, so I just want you to think about it for a second. I'll try and make up a little example to make it easier. Okay, it says there are 3 times as many dimes as nickels in the jar. 3 times as many dimes as nickels. Okay, I'm just going to make something up. So just keep that 3 times as many dimes as nickels in your head for a second. Let's say I had, okay, I've got 3 times as many dimes as nickels. Let's say I had 2 nickels. How many dimes would I have? 6, right? Okay, what did you multiply by 3?